Who first shared their stories in caves, connected art, nature, and science, led us toward new horizons. Who thought to capture motion, spark an engine to life, turn television into a playground. Every day, you create the playful, the functional, and the unexpected. You break down walls and take us to astonishing places. Tell stories, leap borders, and create beauty for tomorrow. Because at Unity, we believe the world is a better place with more creators in it, where everyone has a chance to shape the world.
Hey everyone, welcome to our weekly Unity South APAC webinar series. I'm Sarah from the marketing team, and on the call we have Jenny, who is also from marketing, and our few engineering team, our speaker Shawn, we have Tech, Adam. So a big welcome to everyone joining us from all over the region, from India, Pakistan, Singapore, Australia, New Zealand. Very nice to have you live with us today. Quick reminders about interaction during the webinar. So please put your questions into the Q&A box, not the chat box. The chat box is reserved for links to materials and other resources. And we do not use the raise hand function. The total duration for today's session, including Q&A, would be about 60 minutes. So as always, we do a lucky draw where one lucky registered person who fills in our survey form at the end of the webinar will walk away with a Unity sweat pack. The survey link will be shared at the end of the session. So in case you're joining from a streaming platform like YouTube or Twitch, you can scan this QR code and register to be eligible for the draw. But if you're joining from Zoom already, it means that you have registered and you don't need to do so again. So I'll just leave the QR code here for about a few seconds. And also, we're also giving away a sweatpad to the best question, which we will select at the end of the session. So once again, put in any questions you have into the Q&A box and our Field Engineering team will help to answer them. So these are some of our past winners. Huge congrats. So happy to see all of you, enjoying your sweatpack with your Unity t-shirt. Once again, the QR code is up if you didn't catch it just now. So please scan it. Okay, so we're in the middle of our Building an Arcade Racer series. Today we're doing part 4, Unity Particle System. So as always, we pre-recorded today's session last night to optimize quality. But our speaker, Shawn, and the rest of the Field Engineering team are present right now to answer questions. So with that, take it away.
Hello everyone, welcome to the webinar. My name is Shawn. I am a field engineer at Unity Technologies. And the topic for today is the Unity particle systems. So just to give you an overview of what the agenda is today, we're going to cover what exactly is a Unity particle system. We'll talk about the anatomy of the particle system itself. And then we'll look at how those modules in the particle systems are applied in various ways in this project. There will be a short break where we will field some questions that are lingering in the chat, and then we'll move on with the remaining modules and applications within the project. So what exactly is the Unity particle system? A particle system is basically a tool within Unity that allows you to create special effects for your game. These can include simulating moving liquids, flames, clouds, smoke, magic spells, and a lot more. So I'll start with a little fun fact about the Unity particle system. The built-in particle system that we have today is also known as Shuriken. Back when it first debuted, this was the code name that was used to refer to it. But now that this is our default particle system, we basically just call it particle system. So don't be surprised if you see a bunch of shurikens in your scene view. That's just your particle systems in your game. So let's start by taking a look at how our game has progressed so far. So here's our game. As you can see, it's still a racing game, but with just a couple more flashier elements included in it. So you probably have noticed there's smoke trailing behind the car as it moves along the track. There are leaves blowing in the wind, also settling on the track. There's a pickup, where if you pick it up, there's a special effect that engulfs your character, or your car in this case. There is also a trailing blue particle effects that's emitting directly from the body of the car mesh itself. As you pass the split time gates, they also emit particle effects that signify you passing through them. And I also, of course, added some explosions because that just makes it more exciting. So before diving into each of those effects in that scene, I'm going to go into the basics of what makes up a particle system. To start off, creating a particle system is pretty easy. All you have to do is just go to the Unity editor, hit Game Object on the menu, Effects, and then select Particle System. Once created, you'll see a bunch of floating white blobs spewing out into your scene. So a particle system is essentially made up of two parts. There's an emitter and a particle. The emitter is responsible for spawning particles within a predefined volume or shell called an emitter shape. So on the right, if you observe the image there, you can see there is a blue cage or a cone that forms the emitter shape, and all the white blobs that you see floating around, those are the particle renderers. There's also a nice helpful tool that accompanies your particle preview, and this is called the Particle Effect Panel. This lets you control the playback of your particle system by restarting it or just sampling the particle system from a specific time. So here you can see I'm actually scrubbing through the particle playback time, and this lets me inspect the evolution of my particle effect over its lifetime. Over in our inspector, you'll notice that the particle system component represents both our emitter and the particle renderer all in one. There are three modules that make up the emitter modules. There are general settings, which sometimes also contain settings for each particle in the particle system. And it also contains the shape of the emitter, as well as settings for the emissions, things like the emission rate or the type of emissions that we will talk about soon in the webinar. So the main settings, or the first module in the particle system, are essentially the general settings. This contains settings such as whether or not the particle should loop, the pre-warm, the duration of the particle, and sometimes it also has some overlap with the particles instead of just the emitter. So things like the start color or the lifetime of each particle. Parameters that are universally present in all particle effects are found within this module. The second module is called the emissions module, and this lets you control how the particles are spawned over time. There are a couple of different emitter types, the first of which is rate over time emission. And this lets you spawn particles at a continuous rate, and this is suitable for effects such as fire, smoke, rain, or a stream of electricity. The second emission type is the rate over distance, and this lets you spawn particles as your game object or your transform moves in 3D space. So this makes it perfect for effects such as tire marks, footsteps, or dust trails, as we'll see later on in this demo. The final emission type is the burst emission, and this basically lets you spawn particles all at once or in intervals. So this is perfect for things like explosions or a one-time power-up effect. The third essential module is the emitter shape, and this lets you determine the volume or shell in which the particle effects or each particle will spawn from. There are a lot of different shapes that you can choose from. You of course have your basic shapes such as cone, sphere, hemisphere, donut, box, but we also let you choose a mesh. So you could choose an existing mesh render in the scene or a particular mesh that you've imported into your project. So this is the drink box that you see at the bottom left most. You can also import a sprite and have your particles spawn from the sprite. Or you can have your particles spawn from even simpler shapes that are 2D in nature. You can have it spawn from a circle shape, or an edge, line, or just a simple rectangle. So now that we've covered the basics, we're ready to jump into the project and investigate how to build up these effects from the ground up, from scratch. We'll also look at the effects that we've already built and how to achieve them. So to build up all of our effects, we actually need more than these 4 modules that we've been given at the beginning. You can add more modules by clicking the plus sign at the top right of your particle system. And this opens up a list of different modules that you can pick from. And throughout the demo later in today's webinar, we'll be going through most of them one by one. So we're going to start with a really simple effect, and that's fire. And in this demo, we'll be covering several modules, including the texture sheet animation, the renderer, color over time, and size over time. So here we are finally back in Unity. This is the beautiful car that Tech has made. And we're going to add some flames to set it on fire. So I'm going to go ahead and select this empty game object that I have lying around. I'll go ahead and add a particle system component here. And you can see now it's just spewing up magenta rectangles. Over in the shapes module, you can see that the shape is currently set as cone. That's why it's shooting out in this cone pattern right here. Okay, so I'm just going to go ahead and reduce the start speed to 0 so it doesn't move, and also reduce our start size to 0.1 so that it's a lot smaller. I'll also start to change our shape. Let's look at how this would look like with a sphere shape. This would be perfect for a fireball, but it's not exactly what we want today. Let's look at how we can use a mesh renderer in the scene. So I'll go ahead and drag the body of the car, apply it. You'll see that the particles start to spawn from the body of the car. I'll change this to triangle so it spawns from the face of the polygons, and then bump up the rate over time. And now the particles are spawning from the entire face, all the faces of the car itself. Right? But for today, we just want to set fire to the hood, so I'm going to use a box shape. So I'm just going to go ahead and resize this just to fit the hood of the car, because that's just the only part that we want to set ablaze. So obviously this doesn't look anything like a fire at all. So to get this to start to look like fire, I'm going to actually have to change some settings in the renderer module. So I'll just open it up. And what we need is to assign a material. The material property right now is currently empty. That's why we're seeing magenta. So we're going to find a material. And I actually have to create a material here. I'll create one and call it flame. Okay, let's close that. And what this needs is to be applied to the particle system. So I'll just look for that. And once I've applied it, you can see the magenta is gone and we have the plain old white rectangle look. Next, I'm going to need to apply some texture so that we have what will look like an actual fire. So I'll look into my material, and sure enough, we have a base map property that we can assign our texture to. I have a flame particle sheet here, and it's essentially an animation of a fire laid out in a 6x6 grid. So let's just pull that over and assign that into our base map and investigate further. So of course, it doesn't look like the fire has appeared yet. So we actually need to slice this up to show only one part of the fire. For now, we'll need to know the number of columns and rows in our grid. So it's here we have 6 columns and 6 rows. Right? So we'll take this information and we'll plug it into our next module that I'll introduce now. So we'll go ahead and press the plus sign. And I'll look for texture sheet animation. There it is. And what I'm going to do is just change the X and Y to the columns and rows, which is 6 and 6. And now you can see the fire appearing. To take full advantage of our particle effect, it's important that we assign or use the correct shader for our material. So just go ahead and select the right shader here, Universal Render Pipeline, and then choose Particles and choose Unlit. Okay, and then change this to transparent and change the blending mode to additive. So that gets rid of the blacks when it blends the color to the background. All right, now we see just the flame without the black background. Next, I'm going to change a couple of general settings. So going back to the main settings out here, I am going to bump up the maybe the size of the particle effect. All right, so just have a lot more menacing flame. So that's looking good, but it's a little bit too uniform. Now, if you look at the properties on the right, you can see all these triangles, which you can click and adjust its properties. In this case, we'll change to random between 2 constants, and this allows us to randomize the size of our flames based on these 2 value ranges we've set. Okay, so it looks a little bit more dynamic, more randomized. and more interesting. So next, I'm gonna also randomize the color. So you can do that with color too. I'll set this to a little bit more fiery red, so there's more variation in the tone or the color values of the fire. Let's see what else we can do here. We can also maybe change the color of a lifetime so that the fire fades away rather than just disappear abruptly. So for this, I'm going to add a color over a lifetime. And if I click on that, it'll give me a gradient scale, right? So it's going to the horizontal line represents the time. So I'm just going to add one in the middle, maybe more to the side. So it's going to fade off when it reaches the end of its lifetime and also fade in. So when it starts at the beginning of its lifetime, it's going to be completely transparent and fade into view and then completely transparent again at the end. Right, next, also maybe change the size. So as you can see, the size has already changed here. You'll see that the particles of the fire will actually grow. But instead, I want to adjust this to have it shrink over time instead. So you can see this graph here. The bottom line of the graph represents the time, right? And the vertical line of the graph, vertical axis represents the value. So right now it's constant. So I'm going to add a value in the middle and then just drop the two beginning and end of its lifetime. So it's going to start about there and then start to shrink a little bit towards the end. I think I made a mistake at the weightage there, so just adjust it a bit, right? So it'll grow large and then shrink back down, but not by too much. So at least there's some size variations over its lifetime. Okay, it looks like our fire is looking good. Could maybe just adjust it to, yeah, just add a bit more fire. Yeah, that's looking okay. I'm starting to notice some issues here. If we zoom into this flame, all right, you can see the edges where it intersects with the hood of the car. You can see a clear separation where the fire has these straight lines. So that doesn't really look great in this context here. So I'm going to go into my materials and just check on this feature called soft particles. And that lets us basically blend the particle effects where it intersects with a harsh surface. Right, so if I play it now, you can see it's nicely blending with the hood of the car. All right, lastly, actually this flame that we picked is a bit too realistic. Doesn't really match the stylistic look of the environment. So I actually have a separate sheet here that I'll just use to replace the fire. It's really just a simple, it's the same fire, just put through a crystallized filter in Photoshop. So here it is, the new effect. It seems to be playing a little too fast, so I'm going to go ahead and maybe change the lifetime just to add some randomness to the lifetime as well, and also extend it a little bit more. Right, so it's going to be, some particles are going to live for 1 second and some others will be 3 seconds. And we could adjust the rate over time just to manage this, just reduce the number of particles. And just one more tip, if you were to deselect this particle game object, like say click on an empty part of the scene, you'll see that the animation of your particle effect stops. There is a way to get this playing even though it's not in focus. If you go into the particle effect panel and click on simulate layers, instead of nothing, set it to everything. Now if you select a different part of the, or a different object in the scene, you'll see that all your particle effects will keep playing. Next, we'll look at an effect that uses the rate over distance module. Here you'll notice there are 4 shuriken particle systems placed on the base of each tire here. And all of them have this rate over distance set to 3. So every 3 Unity units, we spawn 3 particles. And here they're quite small, so they don't spawn way too far from its base origin points. Okay, I'm gonna go hit play now and enter play mode. And as you can see, if I do a harsh turn, we'll actually leave tire marks on the track. And this is also possible because what Text has done is really just turn on the game objects for the particle effects when the tire slips on the track. So there's also another effect in here. It's called the tire smoke. That also does the same thing. It's also using rate over distance. So I'm just going to enable that, and you can see it's also going to leave trails of smoke as we do like harsh turns and the tire slips. Let's go closer to the ground and investigate what's happening here. All right, so if we look at the tire marks, I'm going to enable selection on wire and see how this is oriented within the scene. So you can see there's a lot of overlaps between each sprite. And you can change the render mode here. If I change it to the standard billboard, a billboard render mode will basically always face the camera. So if I just rotate this around, the sprites will actually look at me. So you can see the way it's rendered now is a little bit weird. And if I change it to a vertical billboard, it's also doing the same thing, except it doesn't angle in a specific axis. So for this to work, we need to set it to a horizontal billboard so that it always faces upwards in the y-axis. Also, for this tire mark effect, it doesn't actually refer to its start lifetime at all. We're actually using a feature called a ring buffer. And the ring buffer allows you to keep particles alive until the max particle capacity is exceeded. Once it's reached that threshold, it will start to despawn all the earlier particles. Next, we're going to look at how we can simulate leaves blowing in the wind. So we have here the leaves that are set up. First thing you'll notice is that it's using a spherical shape to spawn our particles, and it's spawned over rate over time. It also rotates over time, right, based on a graph curve. So if I bring that up, basically it randomizes between 2 curves from, let's go closer, from 360 to negative 360 here. And to get this randomized curve, you just need to select the triangle and select random between 2 curves. Right, so this is 360s to negative 360, and along the horizontal axis is the time. So what we're looking at here is by 20% of its lifetime, it will actually stop rotating. Right, the rotation value will be 0. So what you'll also notice is that there are no velocity modules in this system, but the leaves are actually blowing thanks to this external forces modules here. And this external forces module interacts with another component called the wind zone. So in the wind zone here, I've set it up. It's just a simple game object where it controls the wind direction using the transforms rotation. Right, so as you can see, if I move the wind zone object's rotation, the leaves are blowing in a different direction. Right, I can also, of course, change the strength of the wind, changing the main values, and then that just determines how far the leaves will be blown. So of course, this requires the wind effect, the wind component, to be a particular layer. So in this case, if I set it to default, nothing happens. If I set it to particle forces, that will be affected. That will be affecting whatever module that also references the same layer. So if I go into the external forces here, you can see in the influence mask, I've also selected particle forces. So I need that 2 linkage over there for the effect to happen. Now here you can also see the particles are also resting on the ground, so your particle effects can also interact with your environment. And for this particular effect to happen, you need the collisions module. So I have this simply just set to world so that it collides with everything. If I turn it off, it would basically just go through the entire plane. And of course, there are a couple of things you can change with the physics. Right? Let me just set this to simulate only in this instance so I don't lag the entire system. If I set the bounce to 1 and change the dampen to 0, you can see that the leaves start bouncing off the ground as they hit the ground. Right, so that's probably not what we want. So I'm going to reset this back to what it was so that it settles and rests on the ground. Now, leaf particles here, they're just resting in the ground and just waiting for our car to run over them. Now we can actually affect the movement of these, or actually wake and add some turbulent forces to these leaves by using a little component called the particle system force field. So here I have a simple game object with that component set up. So you can set it up to repel or attract your particle effects. So what I'm going to do is if I drag this over, it's going to wake and push my leaves all around. And like the wind effect, you also need the game object to be in the same layer for this to work. So there we go. You can see it just pushing all our leaves all around as I move the particle system force field. Right, and next we can see like how this works with the car. If I drive the car through them, because the particle system force field that I have is attached to the car, it's a child of the car game object. I can use the car to actually push all the leaf particles around. Okay, so I've been talking for quite a while now. We're going to take a break here and see if we have some questions in the Q&A that needs some attention.
Okay, looks like we don't have any Q&A, but I'll just bring up some of the questions that were quite interesting in that we answered earlier. So Bhavya Prashant asked that what's the difference between Shuriken particle system and the VFX graph? So that's a good question. The VFX graph actually works on the GPU, while Shuriken is computed on the CPU. So there are pros and cons to each, but mainly because the VFX graph runs on the GPU, you can simulate millions of particles, whereas in your normal Shuriken, which is the one that we're using now, you're usually limited to several thousand before you see some performance impact. However, you do have the ability to collide with your environments with Shuriken. In contrast, your VFX graph wouldn't have access to that. So you have minimal physics in VFX graph. There's ways to simulate that and fake it, but you just don't have the ability to integrate with Unity's underlying physics. Yeah, so those are some of the differences. Other than that, there aren't really, for VFX graph, unrelated to this current webinar, but if you're interested in VFX graph, that's available in URP and HDRP. For URP, you'd have to start in Unity 2019.3. Oh, there are a couple of new questions. Let's check. Could you create a rain particle system that interacts with the track and affects the traction of the vehicle? Would you need to write custom logic for that for that collision? Yeah, you definitely have to write some custom logic for your car to interact with that rain. But you definitely can have your particle system drop to the track and then just sub-emit another particle effect when it touches the ground. Is it possible to develop my game by mobile phone? Unfortunately, at the present moment, Unity is only available on PC and Mac. So you can't run Unity on the mobile phone, but you can build for mobile games. And can I make Unity game without scripting? Yes, you can. There is a built-in package called the Unity Visual Scripting Tool that lets you build your games by just dragging and dropping nodes, logic nodes around to form your instructions for your games. So we actually had a webinar for that a couple of months back. I think it should be in the cycle to play back again in the coming months. So stay tuned for that. There's a question about the camera. I think you can't adjust the camera if you don't create a script to follow the player. You can just use the Cinemachine. The Cinemachine package lets you create a virtual camera that lets you track an object without any scripting. So you can just attach that to a target in the transposer module of that Cinemachine camera, and we'll follow it. And then just apply the same object in the aim component, and you'll have your camera both move to follow the object and look at the object. Yep, glad that helped. I think that's all the questions we have. So we'll continue on and we'll answer the other questions at the end of the webinar.
All right, let's get back to it. We've got a couple more effects that we can take a look at. The next effect is this power-up effect that engulfs the player's car as you pick up the power-up. So I'm going to show you how you can actually build this one from scratch, right from the very beginning. So I'm going to create that particle effect. And you can see it just spews the particle effects all the way up. It defaults to using the cone. So I'm going to change this to something simple like the circle. All right, so now the particles are spawning all around. First of all, I want to reset the rotations first and transfer that over to the shapes rotation instead, so that we keep our transform rotations clean. And then let's set the speed to 0. We don't want it to move around. But now our particles are kind of hidden within the car, so I'll just expand the radius of our circle, and also the inner radius thickness. So now it spawns out of a donut rather than just a circle. And let's go ahead and also add velocity over lifetime so that we can control the movement of our particles. So just go add, I just added the y velocity. We can also change the orbital y so that it spins around the y-axis. And then add a radial value. If I add a positive value, it will spread out. So I want it to spread, sort of attract inward. So I'll add a negative value instead. Next, I'll want to render it in streaks rather than just these individual blobs of particles. If you look at the renderer, there's nothing that we can do, but we actually need to add a new module first. So for this, we're going to add a trail module. And immediately you can see those streaks actually start to follow behind our blobby particle effects. And we're just going to improve the rendering of the trail material. So I'm just going to select the new material for the trail and look for the power-up trail. Oh, it's a bit too bright, so I'm just going to tone this down. And what we can do is really just change the size. So in the trail module, I'm going to look for the width over trail and just reduce this to something more thinner. Part of the reason why it's so intense is because the streaks are pretty long. And the trails are long, it's because of the lifetime. Right, so it's set at 1 second, which is considerably quite long. So I'm going to reduce it to maybe 0.1. You can see we have something that looks pretty good. But now you'll notice that there's some fuzziness in the particles. It's kind of ugly, and we don't really need that. So we can choose not to render the main particle at all, and only choose to render the trails. Next is you'll notice the trails are kind of squarish, so I can change also the width of the trail so that it tapers off at the start and the end. So I'll just reduce the the size of the trail at the start and also the end, so that you have a sharper, sharper trail. Okay, so next we'll just change a couple of settings over here. Maybe instead of a rate over time, we'll change it to burst, so it only spawns once. All right, so right now everything's pretty uniform. So I'm going to make a bit of changes here, maybe in the lifetime. We'll add some randomness, so not all of the trails kind of spawn and die at the same time. Right, so we'll change the lifetime and also randomize the speed of which they go upwards. Okay, 0.5 to 4. Okay, it's pretty intense. Let's just adjust and finesse this as we go along. Okay, let's also maybe adjust the radial values so that it attracts inwards a lot faster. Reduce the duration so we get to preview this a lot quickly too. And let's see, change the lifetime of the trails so that it lasts a little longer. And one thing that you'll notice is that the trail actually pops out of existence abruptly rather than fading off gradually. And this is because it's dying with the particles that is following. So if you just turn that off, the trails will now disappear gradually. And let's just turn off looping to complete the effect. Now it'll just play as a burst when I hit restart. Cool. That's it for this one. Next is the power-up itself, the pickup. Here you can see these tendrils of electricity, and they're actually using the same trail effect with just some modifications to its a render type. So I'll show you how to achieve this lightning effect here. So first of all, you will create a base for this, similar like the capsule. I'll just go ahead and create a sphere and put this right beside. Next, I'll make a brand new particle effect from the hierarchy. You just add effects, particle system. All right, hopefully it spawned at the same place as the sphere. Let's just put it at the edge of it. And let's go ahead and start by changing the shape. Always start with the shape. That's the best way to start with the setting up your particles. Set to sphere. Let's not move the particle effects, and change the radius of the sphere to the smallest so that it spawns in one same location. Next, of course, with the velocity over time, this gives us more control on how to spawn our particles. All right, so right now I think it's, the rotation is off, so I'm just going to reset that so that Y is moving upwards locally. Readjust it to the sphere. And now let's go ahead and add the trail module. So for the trail module, and let's also reduce the size of our particles. Okay, that looks reasonable. We'll tweak that later on. For now, you can see you don't really see our trails just yet. So let's add some noise. Here, noise. Yeah, that's the noise module. So noise module will just add some turbulence into our velocity. All right, just add some scroll to our noise so that we scroll through we sample different part of our noise texture. You can see now our particles are moving erratically, and we can see those trails. I'm going to change the trail to ribbon, and what that does is basically it connects the trail from one particle to another. All right, I'm going to reduce our noise just to keep this more manageable. All right, increase the frequency so it looks a little bit more like lightning. There we go, it's starting to take shape. But it's going to take a bit more time to finesse this a bit. All right, I want the strength of the noise, the turbulence, to kind of change over time. So for this, I'm going to change the value type from constant to a curve. And then I'll bring up that curve editor again. And this should probably maybe reduce the intensity over time. Yeah. So drop that down. I'm going to try maybe the inverse of that. Right, so it actually gets crazier as it ages. Right, so maybe reduce the age, right, so that the lightning is a lot shorter. And let's look at how we can, yeah, let's maybe change this, remove the fuzzy particles, and of course change our material to electric. So now we can actually see our electric taking shape. So change the width of a trail so that the pointy end is thin. All right, this looks like it's the other way around. So if I reduce this, you can see now the end point of that electricity is thinner, and we have a thicker base. And now let's maybe try to smoothen the effect by adding more particles into the emission. All right, all this just, it's more of an art than a science, so you just need to like tweak things and experiment as you go along. So I'm pretty happy with this. We can start to actually just duplicate this and put it all around, and this will form our electrified power-up. Right, so I'll just go ahead and duplicate that and rearrange it around. Put it at the side, and then just keep duplicating it and moving it to a different orientation in the sphere, and you have your new electrified, super-powered power-up pickup. There you go. And now for one of my favorite effects, explosions. So this effect utilizes a couple of different modules as well. It of course bounces off the ground, so you know that it has collision, but it also has several particles strung together, so it's using something called a submitter. Let's inspect these one by one. First, I'm going to turn on this show only selected option so that I only see one particle effect at a time. So we have here the first particle effect is just a burst particle that just creates a mesh, and that mesh is a sphere, and all that is it just has a glowy material, right? So it's just going to blast the sphere. It'll also grow over time, just grow a little over time, right, with a very short lifespan. And of course it's a burst like we mentioned, and this is all it does. The second effect is this debris effect, which is the same glowy particle effect but also collides with the ground, right? So it also has the emission type is also burst, but it spawns a higher count. It also has a gravity modifier so that it falls to the ground. It spawned as a hemisphere, so it spawns upwards. So all the emissions are spawned upwards with a standard start speed randomized between two values, so that when you spawn in a hemispheric shape, it spawns upwards. And of course you have the size over lifetime that forces it to shrink. So you see it shrinks to a certain size. It also rotates just to not make it feel so rigid, And of course, it has collision, which allows it to bounce off the ground. And finally, the new module is a sub-emitter. So the sub-emitter references two additional particle effects. One is the trailing smoke and one is the trailing fire. And these are emitted when the particle is born. All right, so this is the smoke particle effect. It just has some wispy noise to it. And this is the trailing fire. All right, they're quite similar, except that they both are sub-emitters of the main debris, so they follow where the main debris spawns and moves. We can actually add another component to spice things up. We can add lights to the explosion. So add a light component or light module, and we need a light for this to reference. So all you have to do is the same way you create any light, just go into the hierarchy, lights, and you choose point light, add it to as a child of the debris, and then you can just drag the point light over, assign it as a reference, set ratio to 1 so that all your debris effects have light. So you can see now it's shining some light to the ground, and all you have to do is just tweak the range and the color and just have that and just preview that and see how that affects your scene. So I'm going to set it to, of course, use the particle color. Our particle color is currently just pure white, so I'm going to adjust that to add some color to it. And now you can see the light that it emits out is following the particle start color. Lastly, we're going to look at how the smoke is done in the scene. All right, so look at this. The smoke isn't actually that great. It's just made of spheres, and you can actually see the shape of the spheres quite clearly. If you look at it from this angle, you can see that the wispy smoke, the smoke texture doesn't really evolve over time. It's just it's just plainly a texture mapped onto a sphere, which is not very exciting or natural. If we look at our shader that we've made in shader graph, you can see in this particular setup, we're using a smooth step here that can potentially cut off parts of our image based on the values of the texture. So we have a texture that's purely black and white. This is cloud texture, kind of generated in Photoshop. And we have this float node that's plugged in. And if I raise this float value from 0 to 1, notice that if it reaches the value of 1, the blacks start to take over, and in the main preview at the bottom, you notice that it also starts to disappear, right? So we're slowly cutting off the visibility of our smoke as we raise that float value. Right, so what we can do is actually have our lifetime somehow affected so that as it ages towards the end of its life, the smoke starts to dissipate based on this texture. Right, we start to cut off the visibility of the texture based on that. So what we can do is use this thing called a custom vertex tree that's under the renderer, and you can just go ahead and select all of these tire mesh, so we make sure we affect all of them at once, and actually add a custom vertex stream that we pass to our shader. So over here you can add things like rotation and all that, but what we want is this H percentage. You can see in H percentage, in brackets it has something called text coordinate 0 dot z. Let's zoom in closer. Text coordinate 0 dot z. Right, so this is going to be passed into our shader, and this is represented by this UV node here. And within this UV node, you can see there's a bunch of channels, and because it's text coordinate 0, that's UV0. So to figure out how we get Z inside our shader, let's list out what we usually see in the color channels. We have RGBA from color channels, and then XYZW from our custom vertex tree. You can see this matches up, right? The R is X. So in this case, RGB, B would be Z. So I'll go ahead and plug that into our smooth step, And now our particle lifetime would affect how our texture fades out. So now you can see in our smoke, let's unfilter this. In our smoke, you'll see now it's rather than like the sphere, a texture back to a sphere, you can see now the textures actually dissipate, right, based on their pattern. Right, so if I now start playing and make this harsh turn so I can look at the smoke, right, we get a more wispy looking smoke. It's almost feathery looking. Right, so there we go. That's how you create that smoke effect. And that's it for this webinar. Thank you for joining me, and I hope you guys learned something new in today's particle effects webinar. If you have any questions or would like to reach out, here are my contact details and my socials. And with that, it's time to move on to Q&A.
Okay, so we don't have any more lingering questions, but we did answer quite a few really good questions in the chat. There's a couple from, there's one from Joe Adams. Instead of manually placing multiple instances of the lightning particle, this is referring to the pickup effect that we had earlier. Could you not just, he asked that, could you not just create another particle system to randomly spawn the lightning particle from the surface of the para? You definitely could. That's a great observation. So we did also show that you could spawn the particles, emit them from the vertices of your mesh. So you could do that as well instead of manually placing them. The benefit of placing them manually is, of course, you can control the actual, the final placement manually. You can curate it. But if you want something that's more erratic or unpredictable, you can definitely do that. There's a couple of other questions are more related to getting like earlier webinars. So if you're not aware, this current webinar that we're doing is part of a series. So today we're covering particles, but before that, Hector covered input systems, and Tech also covered creating the actual racing mechanic, the car mechanics.
So we've just shared the survey link in the chat box. Please take a moment to fill it in if you'd like to stand a chance to win a Unity Swag prize pack. On that note, Shawn, would you like to share today's best question?
Oh yeah, definitely. I think the question that Joe Adams posed earlier about that placement of lightning particle effects, that was a great one. It's a fantastic observation from him. So I'd give it to Joe Adams.
All right.
The rest are, I think there was a follow-up question for using VFX Graph. So VFX Graph is available for only the universal render pipeline and the high definition render pipeline. If you're using it for URP, you'd have to be using Unity 2019.3 onwards. So make sure that you're on that version before you make the jump. Yeah, I think there's no other questions except this one from Draco, which is quite interesting. We'd like to ask just a casual question of how to get back the motivation of learning and working on a project with Unity. Thanks. That's a great question. So I think Tech answered this for me as well. For Tech, I'll answer for him. Like for Tech, the greatest motivation came from just finding something that you can be passionate about. For himself, a recent example is really getting into game physics, which started off relatively straightforward, and then he ended up diving off into the deep end and started having fun digging into custom physics and how they can affect gameplay. I think he did quite a lot of research, watching a lot of GDC talks about how other developers have been doing it, how actual real car physics works, and then he reinterpreted in his own way. For the tire trails, can you use a trail renderer passing an alpha value into the color depending on the tire slip angle, and use that in case instead of a lot of small horizontal particles? You can, yeah, you still have to sort of angle the facing direction of your particles so they render out correctly. Okay, I think there aren't any more questions, Sarah. Oh, there's one more. Oh, that's just a thank you. You're welcome.
Awesome. So with that, we can wrap up today's session. I'll be contacting the winners of our Unity Swag Prize Pack later on. And please join us for the last session next week, where we wrap up the Building an Arcade Racer series with machine learning agents. Thank you all for joining